Hello and welcome back. Today we're talking about the R-squared, a very important concept when it comes to evaluating the goodness of fit of our models. Now, in order to understand R-squared, we're going to need to look at two versions of our chart. So here is our data set, and what we're going to do here is plot the regression as we were doing before. And here's our data set again, and this time we're going to just plot an average line, and we'll see that in a second. So we'll start with the regression. Let's draw our regression line. As usual, let's project vertically our data points onto it. And for each data point, we're going to look at the difference between yi, the actual value, and yi hat, the predicted value. Now, as we discussed before, the way we built this line is we're minimizing this sum over here, and that is the ordinary least squares method. Well, actually, this sum has a name. It's called the residual sum of squares, and it's indicated by this abbreviation. Now, on the right here, we're going to draw an average line, and this is simply taking all of the y values, so the actual values of our data set, the y values, and taking their average. Again, we're going to project vertically our data points onto this line, and for each data point, we're going to look at yi. And here we're going to calculate another total, and this one is called the total sum of squares and is indicated by this abbreviation. And it's similar to the residual sum of squares, but instead of using yi hat, we're looking at the difference between yi, the actual value, and y average, the average value of our data set. And now we can calculate R-squared. R-squared is defined as 1 minus the ratio between the residual sum of squares and the total sum of squares. Now let's pause here for a second and discuss this a bit. So we know that we're minimizing the residual sum of squares. We want to make it as small as possible. And from these two images, you can already see, just by judging based on the lengths of these blue dashed lines, we can see that they're generally longer on the right, where the average is, and they're shorter where the regression is. And that's because we've designed our line to minimize these lengths, so the sum of squared is smaller. And so what that means is that the residual sum of squares is usually, in most cases, it's less than the total sum of squares. So the way to think about it is in the total sum of squares on the right, you're just putting an average line. You're not modeling anything. This is the most rudimentary thing that we can do, is just put an average line and approximate our data with that average line. Of course, it will be, and it should be, worse than any thought out model that we create, which is the example on the left. So thereby, unless our regression model is facing absolutely the wrong way, for example, a downward slope on the left over here, if our model was sloping downwards, then the residual sum of squares would be huge because our model is just incorrect. But in all other cases, the residual sum of squares is less than the total sum of squares. And what that means is that the ratio is less than 1. So R-squared is somewhere between 0 and 1. And the better our model fits the data, the smaller the residual sum of squares will be, and that means the greater R-squared will be. So here's a quick rule of thumb for R-squared. Now, bear in mind that it highly depends on the context, and this rule of thumb is just for the practical tutorials that we're looking at in this section of the course. And here we go. So if you have a 1, R-squared of 1, that's a perfect fit. That means the residual sum of squares is 0, and basically your line is going through all the data points, which is virtually impossible, so it's very suspicious. If your R-squared is about 0.9, that's a very good model. If your R-squared is less than 0.7, it's not a great model. It's not the end of the world, but not great. If it's less than 0.4, it's quite a terrible model. And if it's less than 0, then the model makes no sense for this data, as we discussed. So there we go. That's how the R-squared works. A very important concept to understand because it's used quite a lot to evaluate models. I look forward to seeing you next time. And until then, enjoy machine learning.